Okay, so this is the final video from section 5, 5.4, with more examples of solving rational inequalities. So right now I'm going back to your textbook, and on page 373 I want to solve exercise, not exercise, but problem 33. Okay, so we need to solve this rational inequality x plus 1 over x minus 1 greater than 0 algebraically. So this is nice inequality because you already have a 0 on the right side. So we don't need to get common denominator. This is very easy rational inequality to solve. So first, what you're going to do here, first, find x-intercepts. By making numerator equal to 0. So we're going to take that x plus 1, make it equal 0, and we're getting that x equal negative 1. It's our 0, it's our x-intercept. So we already have one number, on a number line, because we eventually will get into the number line in intervals to do the test. Now, in this inequality, make sure that you're paying attention to inequality symbol. This is strict inequality. So in this case, x-intercepts will have an open circle. It's not going to be part of the solution, okay? Because we don't have that equal sign. Second, we need to find the undefined values of this inequality by making denominator equal to 0. So our denominator is x minus 1, solve for x equal 1. So for x equal 1, this inequality is undefined. So put it that way. For x equal 1, the inequality x plus 1 over x minus 1 greater than 0 is undefined. So that's the second point, which will be on our number line to create the intervals. Also, for undefined values, you always keep the circle open. It doesn't matter what is the sign of the inequality. So third, we're ready to create a number line and intervals. So create the intervals using X-intercept and the undefined value and do the test. So I combine that. I give you so many steps in the previous video. Here we're just catching up. Okay. So let's rewrite, so we don't have to go back and forth, that we're solving inequality x plus 1 over x minus 1 is greater than 0. So next, when you have your x-intercept, which was equal negative 1, open circle because of the strict inequality, so that was your x-intercept, and undefined value is for x equal 1. Undefined value always have open circle. Those two values divide the number line into 3 intervals. And our job is to check which intervals satisfy our inequality. So we have 3 intervals. The first one is from negative infinity to negative 1. This one, the second interval, it's from negative 1 to 1, parenthesis. And the last one, it's from 1 to positive infinity. So we have to check which interval will satisfy our inequality. So we're going to test. We're going to pick a number from each interval. I'm going to start with the left one. I'm going to pick any number from negative infinity to negative 1. So I will pick x equal negative 2. Plugging in, substitute negative 2 for x from inequality, and I will check if that will give me positive value. Because again, we're looking for positive values. Okay, so we're going to have negative 2 plus 1 over negative 2 minus 1. And again, we're checking if that will give you positive value. So we're having negative 1 divided by negative 3. Check if that's positive. You're getting 1 over 3, which is definitely positive. So this is true. Okay. Any number from interval negative infinity to negative 1 will always satisfy the condition of the inequality. You always get positive value. What that means, that the interval from negative infinity to negative 1, it's the solution. So yes. Okay, so we have yes. Now we're going to do the same work for the second interval. So we're going to pick any value between negative 1 and 1, pick the easiest possible, which will be 0, and replace x with 0. So we're having 0 plus 1 over 0 minus 1, and I'm checking if that will give me positive value. So we're having 1 divided by negative 1. We'll check if this is positive. We got negative 1, it's greater than 0. This is not true. So that's not our solution. So the interval from negative 1 to 1 is not a solution. And one more, okay? Let's pick any number from the last interval. So last interval is from 1 to positive infinity. I'm going to pick x equal 2. So I'm going to replace x with 2. So I have 2 plus 1 over 2 minus 1, and I'm checking if that will give me positive. So we're getting 3 over 1. Check if that's greater than 0. 3 is greater than 0. That's definitely true. Okay, since this is true, that means the interval from 1 to positive infinity is the solution. So yes, solution. So we have 2 intervals which satisfy our inequality. So we're going to write down the answer. Our inequality is positive for x values from negative infinity to negative 1, union from 1 to positive infinity. So that's the final answer. Okay. And I want to do one more. They suggest 39, so let's do 39. So I'm going back to the textbook. One more example. This is page 373, number 39. One more, so that will be the last example. We need to solve rational inequality. Okay, algebraically. Okay, so in this case, we need to do a little more work because you don't have a 0 on the right side of the inequality. So step 1, you have to rearrange the inequality. So we have 0. On the right side. Okay. So to be able to get 0 on the right side, we'll need to subtract 1 from both sides. So we have x plus 4 over x minus 2 less than equal 1. Subtract 1 from both sides. And we're getting x plus 4 divided by x minus 2 minus 1, which is the same as 1 over 1 less than equal 0. So next what you need to do, step 2, you need to find common denominator. And simplify the left side. So the left side of the inequality has to be fraction of numerator over denominator. That's it. So x plus 4 over x minus 2 minus 1 over 1. Since we're subtracting 1, it's very easy to find the common denominator, which will be x minus 2, because to find the common denominator, you just multiply denominators together. So x minus 2 times 1 will give you x minus 2. So x minus 2 is our common denominator. Okay. So x plus 4 over x minus 2, since we already have that x minus 2 right here, minus, and then here in the second fraction to get that common denominator, that works similar to cross multiplication. You multiply 1 by x minus 2. So you have 1 times x minus 2 over x minus 2. Okay, so like you see, we didn't change the left side because x minus 2 divided by x minus 2, it's technically 1, but we doing this operation to get the common denominator. And like you see, x plus 4, it's still x plus 4, because if you multiply x plus 4 by 1, you're getting the same thing. So let's simplify that. We're going to put one common denominator, which is x minus 2, on the bottom. And numerators, you combine them. So you have x plus 4 minus 1 times x minus 2. That will give you, first you will need to distribute negative 1 to x and negative 2. So you have x plus 4 minus x plus 2 over x minus 2. So all the work which you see, I'm simplifying the left side. So x and negative x cancel, and you have 4 plus 2, which is 6 over x minus 2. So we simplify the left side, and now we're going back. Don't forget that you're solving inequality. So this is the left side which we simplify, and our inequality, we're solving that. That will give you less, has to be less or equal to 0. So I'm copying the rest. This inequality has to be negative or 0. So since we have that, we find the common denominator and simplify the left side. So that's the inequality with which you work. And we're going to move on to step 3. Step 3, find the X-intercept. So to find the X-intercept, you make your numerator equal 0. So we have 6 equals 0. This is not true. So what that means? We don't have X-intercept, which is fine, okay? It can happen. We still can solve it. Step 4, find the undefined value of our inequality. So the undefined value for our inequality, again, inequality is 6 over x minus 2 less than equals 0. To do that, you take denominator and you make it equal 0. So we're doing something what we're not supposed to do. Solve for x, and we're getting x equal to 2. So this inequality is undefined when x is equal to. Now when you have undefined value, we're moving to step 5, create the intervals using X-Intercepts and the undefined values. So then do the test. Okay, so this is our number line. The solution of inequality, it's in terms of x values. We have negative infinity and then we have positive infinity. Since we don't have the x-intercepts, we only have undefined value, which is x equal to. For undefined value, you're always going to have open interval. It doesn't really matter if your inequality has equal sign here. Since x, that inequality, when x is equal to, it's not true, it's not real, you always keep the interval open for undefined value. So the circle will be open. No x-intercept, so we're not putting anything on the number line. And this inequality will be easy to solve because our number line was divided into two intervals. The first interval is from negative infinity to 2. The second interval is from 2 to positive infinity. So we need to check which intervals satisfy the inequality. Okay, so don't forget that we're solving 6 over, this is our inequality, 6 over, let me just rewrite that, x minus 2 less than equals 0. So I just put that inequality here. So we're going to do the test. Okay, first I will work with the first interval. So I'm going to pick any x from the interval from negative infinity to 2. I will make it easy, pick x equals 0. So then we're having 6 divided by 0 minus 2, and I'm checking if that inequality will be less or equal to 0. So we're getting 6 divided by negative 2. Check if that will give you 0. Less or equal to 0, you're getting negative 3 less or equal 0. Negative 3, definitely it's less than 0. So this is true. Okay, so yes, the interval from negative infinity to 2 satisfy our inequality. So that will be 1. Okay, still don't ignore the second interval. Let's just do work. Always check. Okay, so next interval is 2 to infinity. So pick any value from 2 to infinity. I will pick x equal 3 and substitute 3 into your inequality. So we're getting 6 over 3 minus 2. You're checking if that will give you less or equal to 0. So let's check that. So we're getting 6 over 1. We're checking if that's less or equal to 0. We're getting 6 less than equal to 0. Like you see, this is not true. Okay, so this is false. So what that means, interval from 2 to infinity is not a solution. Okay, so this one, it's not going to work. And now we're going to write down the final answer. So the solution of this rational inequality, it's interval from negative infinity to 2. So don't forget that this is interval notation. I really like interval notation, but there is no mistake to put answer that way, that x is less than 2. That's inequality notation. So of course they both are represents the same thing. Okay, that's it. This is the final video from section 5.4.